This lesson is on graphing linear inequalities. So hopefully you've already graphed linear equations because I'm going to assume that you already know how to graph those. All right, so the difference between a linear equation and a linear inequality is the inequality symbol here. So if this was a linear equation, it would be an equal sign. So linear inequality, you've got an inequality symbol. And linear means that this is going to graph as a straight line. So here's the first thing I'm going to tell you about graphing linear inequalities. If your symbol is less than or greater than, then the line you're going to use is a dashed line. If your inequality symbol is greater than or equal to, or less than or equal to, you're going to use a solid line. So if it's not or equal to, it's dashed. If it is or equal to, it's a solid line. Excuse me. So let's look at this linear inequality. So y is greater than x minus 2. Again, hopefully you've already done linear equations and you know that this is in slope-intercept form. So slope-intercept form is mx plus b, where m is the slope and b is the y-intercept. So the slope of this line is the coefficient of x, which is 1, and I'm going to rewrite that as 1 over 1 because to graph this, we're going to use rise over run. And the b represents the y-intercept, which in this case is negative 2. So the first thing you want to do is graph the y-intercept. So I go to negative 2 on the y-axis and I put a dot. Then I'm going to use rise over run to find my next point. And all you need are 2 points in order to draw a line. So the slope is positive. I know the line needs to lean to the right. So I'm going to rise 1 and run 1. So up 1 over 1 going to the right so that the line leans to the right. All right, now the next piece of this is that we have to remember that we're going to use a dashed line. So I kind of cheated and I already have a line here. So there's my line. And I'll put arrows on the end of this because it continues in both directions indefinitely. And so far, the only difference between graphing this and graphing a linear equation is that it's a dashed line. Now, keep in mind, if it's or equal to, it would be a solid line. But there is one other piece to this. And the other piece is that in a linear equation, the solutions to the equation are on the line. So all the points on the line are solutions to the equation. Well, in a linear inequality, the solutions are actually above or below the line. And the way that you know whether it's above or below is if the symbol is greater than or equal to, then we shade above. And if the symbol is less than or equal to, then we shade below. All right, so let me get, let's see, we'll use a crayon. How about that? So let me get my purple crayon. And since this is greater than, we are going to shade above the line. And what this is saying is that any point in this shaded region is a solution to the inequality. Let me widen this up so we have more room here. So any point in this shaded area will be a solution to this inequality. So let's pick an easy point. So let's look at the point 0, 0. All right, 0, 0 is in the shaded region. So if I plug 0, 0 into our inequality here, so plug in 0 for x and 0 for y, what I would get is 0 is greater than 0 minus 2, or 0 is greater than negative 2. And that's true. So 0, 0 is a solution to this inequality. Now let's pick a point that's below the line and see if that point would work. So what's an easy point? Let's do a point. Let's do this point here. So this point is 0, negative 4. So this is below the line. It's not shaded, so this should not be a solution. So I'm going to plug in 0 for x and negative 4 for y. So that would give me negative 4 is greater than 0 minus 2. Negative 4 is greater than negative 2, and that is not true. So the fact is, any point below this line will not be a solution to the inequality. Any point above it will be a solution. Now, the reason the line is dashed is because points on the line are not solutions to the inequality. If this was a solid line, then the points on the line would be solutions. All right, so quick review here what we did. This was in slope-intercept form. So the slope was 1, the y-intercept was negative 2. So I graphed the y-intercept at negative 2. And then I did rise over run, rise 1, run 1 to get my other point. Since it is not or equal to, so right here, greater than or less than is a dashed line. If it's or equal to, it would have been a solid line. So I used a dashed line. And then the other rule is, if it's greater than or equal to, then you shade above the line. If it's less than or equal to, you shade below the line. All right, so let's look at another one. So we have y is less than or equal to 1/2 x plus 1. So the slope of this one is 1/2, that's the coefficient of x, and the y-intercept is 1. So we graph the y-intercept at 1. Again, we have a positive slope, so we're going to rise 1, run 2. So I went up 1 and to the right 2. And I think I cheated again. Yep, I did. Here's my line already down here. All right, let me put arrows on the end of this. And now this one is less than or equal to. So I forgot to mention, look, it's a solid line this time because it's or equal to. And since it's less than, we're going to shade below the line. So shade below the line. So let me grab my crayon here. I'll use blue this time, and I'm going to shade below the line. And so again, what we're shading are all of the solutions to this inequality. So any point below this line here in the shaded region would be a solution to this inequality. It would make it true. Any point above would not. And since the line is solid, that means points on the line are also solutions. All right, so let's look at another one. All right, this one's in standard form. And what I want you to do with these, this is different than what I've previously taught. I want you to change this into slope-intercept form. So that means we want to get the y by itself. So we want to get this into y mx plus b. All right. And so I'm going to subtract 2x from both sides, minus 2x. So I have negative 3y is greater than 9 minus 2x. I'm going to divide by negative 3, and I have to divide everything by negative 3. Now here you have to be really careful. Remember, when you're solving inequalities, if you ever multiply or divide both sides by a negative number, then you have to flip the inequality. So I'm dividing by a negative number, so I have to flip the inequality. So I end up with y is less than negative 3, a minus and a negative make this a plus 2/3 x. And to really make this in slope-intercept form, I'm just going to flip these around. But you could leave it the other way. All right, so we've got a slope of 2/3, so that's a rise of 2 and a run of 3. And we have a y-intercept of negative 3. So I go to negative 3 on the y-axis, and I'm going to rise 2 and run 3. 1, 2, 3. And I don't think I have a line this time, so let me Get my line maker here. Oh wait, is it solid or dashed? Oh, it's going to be a dashed line this time. So dashed line. Let me extend this out the other way. So again, if it's or equal to, it's a solid line. If it's not or equal to, then it's a dashed line. So it's a dashed line. This, now again here, this is really important because originally this was greater than, so I would have shaded above. But because I divided by a negative number, it became less than, and now I'm going to shade below. So let me get out my crayon. I'll use green this time. Shade below the line. So every point below the line is a solution to the inequality, meaning it makes the inequality true. And any point on the line is not a solution. That's why the line is dashed. All right, so on this one, it was in standard form. I solved it for y to put it into slope-intercept form. That helps me in figuring out which way to shade. All right, so what about horizontal and vertical lines? So x greater than -1. So I know it goes through -1 on the x-axis, and it only can go through -1. So this is a vertical line, and it's dashed because it's not or equal to. So in this one, how do I know which way to shade? Well, if it's greater than or greater than or equal to, you shade to the right. If it's less than or equal to, you shade to the left. So a vertical line is different. So in this one, it's greater than, so we're going to shade to the right. So that's over here. Change it up and use my highlighter this time. I like the crayon better, I think. All right, so with a vertical line, if it's greater than, then you shade to the right. Less than, you shade to the left. All right, y less than or equal to 2, that is a horizontal line going through 2 on the y-axis. And this time it's a solid line because it's or equal to. And this one I use the same rules before. Less than, shade below, greater than, shade above. So this one's less than, so we're going to shade below. Ooh, paintbrush. How about that? Let's try that. How's that work? Ooh, fancy. All right. So again, what we're showing are all of the solutions. So here's a quick summary of this. All right, so less than or equal to, shade below the line. Greater than or greater than or equal to, shade above the line. If it's a vertical line, you shade to the right of the line. If for greater than, sorry. So if it's greater than on a vertical line, you shade right. Shade left if it's less than. And then the only other piece I didn't write on here is it's a solid line if it's or equal to. It's a dashed line if it's less than. So I should add that on here. So let me do that. That would be good to have on here. So if it's less than or equal to or greater than or equal to, it's a solid line. If it's less than or greater than, it's a dashed line. All right, so I hope that was helpful to you. If you need to, back it up and watch some of the examples again. All right, there's a lot of information there in just a little short amount of time. Until next time.